In FastAPI, you can define a path operation with either async-def or plain-def, and both look almost identical. But under the hood, they behave very differently, and picking the wrong one can quietly block your entire server. In this video, we will clear up exactly what each keyword does and when to reach for it. FastAPI runs on a single-threaded async event loop. That loop can handle thousands of requests concurrently, but only if no single operation hogs the thread. The moment you make a slow blocking call, say a database query, without telling the loop to step away, every other request waits. Async-def and plain-def are the two tools FastAPI gives you to handle this correctly, but they work in completely opposite ways. Think of the event loop as a single head chef. When that chef uses async-def, they personally manage the waiting. They start a slow task, yield control, and come back when it is ready. When they use plain-def, FastAPI sends the work to a pool of kitchen assistants, separate threads, so the head chef never has to wait at all. Both strategies keep the kitchen moving, they just delegate differently. With async-def, your function lives on the event loop itself. Every time it hits an await expression, it pauses and hands control back to the loop, so other requests can run. With plain-def, FastAPI detects that it is synchronous and runs it inside a thread pool, a set of worker threads managed by Python's concurrent.futures. The event loop stays completely free while that thread does its work. The key insight is that FastAPI handles the thread pool for you automatically. You do not wire it up yourself. Here we have two path operations on the same FastAPI app. The first, get_weather, is declared with async-def. Inside it, we use httpx.async and async-native HTTP library. The await keyword on the get call tells the event loop to go handle other requests while the network round trip completes. The second, get_report, is plain-def. It calls time.sleep, which is fully blocking and synchronous. Because we use def instead of async-def, FastAPI automatically sends this function to a thread pool, so the event loop thread is never held up by that 2-second sleep. The sharpest difference is where execution happens. Async-def keeps everything on one thread and relies on cooperative yielding via await, no thread overhead, but one forgotten blocking call can freeze the whole server. Plain-def gives up on single-threaded efficiency and instead uses a thread pool which is inherently safe for blocking libraries, but comes with thread pool limits and context switch costs. Neither has a performance edge in isolation. The right choice depends entirely on what your libraries support. The decision comes down to one question: does the library you are calling support async and await? If yes, use async-def and await every call that does I/O. If your library is synchronous, and many excellent ones are, use plain-def and let FastAPI handle the thread pool for you. When in doubt, plain-def is the safer default because FastAPI's thread pool will protect the event loop. The only cardinal rule is never call a blocking function inside async-def without an await. That is the mistake that silently kills concurrency. To wrap up, async-def and plain-def are two strategies for the same goal, keeping FastAPI's event loop free. Use async-def when your libraries speak async and you can await every blocking operation. Use plain-def when your libraries are synchronous and trust FastAPI to offload them to a thread pool. The match between your keyword and your library is what matters. Get that right, and FastAPI's concurrency model works exactly as intended.